Hey guys, welcome to the pre-algebra video 12.5. We are talking about reflections and symmetry today, which we can see here, here, and here. We're going to talk about all those different kinds. And yeah, so hang on. All right, so what's a reflection? Well, it's just a type of transformation, okay, or translation, which we have talked about, in which a figure is reflected or it's flipped across a certain line. Okay, now that line is going to be called the line of reflection. What is that? Well, it's just the line across which a figure is flipped. Okay, so let's just real quick just take a glance at this, and without really doing any calculations, it looks to me like a reflection. Okay, and it looks like it reflects from one image to the other across this axis right here. Okay, now what is that axis called? Well, it's the, even has it right there. It's the y axis. So we would say, if we were asked, is this a reflection? We'd say, yeah. And what's it reflected across? It's reflected across the y-axis. All right, so we're going to talk about some common reflections. And the two most common that we're going to see are reflection in the x-axis and reflection in the y-axis. Now, it sounds kind of strange, reflection in the x-axis, but think of it like reflection in the mirror, right? We talked the same way about that. So let's label some points real quick here on reflection in the x-axis. So we have, let's see, -2, 3, and 4, 1. And then we have -2, -3. And then we have 4, -1. And so I'm beginning to kind of see a pattern. Maybe you are, maybe you're not, and that's okay. But let's look at these 2 points first of all. We have -2, 3 and -2, -3. So do we notice a change in the x-coordinate? No, it's -2 in both spots. But what do you notice about the 3's, okay? Or the 3 and the -3? Well, one is positive, one's negative, so they're opposites. So maybe we're starting to notice a pattern. Let's check it on the other point, though. 4, 1 and 4, -1. Again, the x-coordinates, the 4's, stay the same. But the y-coordinates are opposite. Okay, so what we see in reflection in the x-axis is that you multiply, okay, the y-coordinate by -1. Okay, so if you want to take this and reflect it in the x-axis, multiply the y-coordinates, both 3 and 1, by -1 to get -3 there and -1, but keep the -2, keep the 4, keeping the x, okay, coordinates. So when we reflect in the x-axis, we multiply the y's by -1. So when we reflect in the y-axis, we are going to multiply the x-coordinates by -1. Multiply x coordinates by -1. I should have typed it last time, but okay. So what I want you to do is I want you to reflect what I'm about to draw across the y-axis. Right there. So pause the video, reflect him across the y-axis, or reflect him in the y-axis, and let's see how you do. Now we could probably eyeball it and go, okay, well, it's here at -2, it's 2 that way from -2, so we can go 2 this way. Yeah, that's true. But some shapes are going to be a little more complex. Might not be as beneficial to do that. So again, we have a kind of algorithm we're going to follow, and that is we are going to multiply the x-coordinates by -1. So here, this was the point 2, -2, and this was the point 5, 1. So if I multiply the x-coordinates by 1, well here, well, 2 is the x-coordinate, and I need to multiply it by -1. So I'm going to have -2 as my new reflected x-coordinate. But my y-coordinate, I'm not going to touch. I'm going to leave as -2. Now up here, I'm going to multiply that 5 by -1 because he's the x-coordinate. So 5 times -1 is -5. So we know we're going to be over here somewhere on that. Okay, so it's going to be -5. And then I'm going to leave the y-coordinate 1 by itself. So where's the point? -5, 1, left 5, up 1. And there you go. this black line is the reflection in the y-axis of the orange line or line segment. All right, so what I want you to do is pause the video, and I want you to ponder if there's a reflection here. And if so, I want you to tell me which axis there's a reflection in, and then play the video and let's see how you do. Okay, so as I look at this, my initial thought is, oh yeah, there's a reflection. There's a shape here and the same thing looking down here. So yeah, probably a reflection in the x-axis. But let's see. Remember, when we reflect across or in the x-axis, when reflecting in the x-axis, we multiply the y-coordinates by -1, but we actually leave the x-coordinates alone. So the first thing I probably need to do is, mark some points here and then identify their coordinates. So for example, let's just stick with this one first. Okay, his coordinates are -5, 5. Okay, so his reflection, that corresponding point should be, well, let's see. Remember, we're checking if it's reflecting across the x-axis, so if it is, we're supposed to multiply the y-coordinate by -1. Okay, so the y-coordinate is 5. So 5 times -1 is -5. So really our new point should be at -5 because we leave the x-coordinate alone, and then we multiplied this by -1 to get another -5. So let's find the point -5, -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, well, there's a point there, so maybe it's reflecting. Let's try another point. Let's try this one right here. Okay, so his coordinates are -2, 3. Again, his reflected point should be, well, leave the x-coordinate alone, and the new coordinate, so -2, and then the y-coordinate, we need to multiply the y-coordinate by -1. So what's 3 times -1? -3. So let's plot the point -2, -3. Left 2, down 1, 2, 3. Uh-oh. So what's happened? Well, we actually did this correctly. We reflected that point accurately. But we're finding that, man, we're probably not going to end up getting what we thought we were going to get, or what we're getting is actually not a reflection. Okay, so what we would actually find is if we reflected the rest of these points, here's where they would lie. So this one would be there, okay? This one, this guy would reflect to there, okay? So it's like we have two that are the exact same, but then if we reflected this point right here, we would actually get him to be right there. So if I connect all my new dots, it would look like, I'll do it in green so we can tell the difference. Like this, like that, and like that. And if you really look at that, I'll kind of color it in so we can see, that shape actually does look more like a reflection in the x-axis of this original black trapezoid there, okay? So what we found was actually it did not initially reflect, but we did find what the reflected image should be. So the next thing we'll talk about is line symmetry. Okay, what is line symmetry? Well, line symmetry simply divides a figure into two parts that are reflections of each other. So looking here, we can see that a triangle, okay, an equilateral triangle specifically, has three lines of symmetry, okay? If we cut it there, we could fold this piece over onto this piece and it would be equal. Okay, square, we can see it's got 4. Pentagon has 5, and a hexagon has 6, okay? Maybe a little pattern there. Now, like this flower here, we actually have how many? Well, this is 1 all the way across. So 1, 2, 3, 4, 5, 6. Okay, 1 again, 2, 3, 4, 5, and 6. Okay, so it's got 6 lines there. So why don't you take a second and tell me how many lines of symmetry each of these have, and then see if you can guess what flag they are. Okay, so this is actually the Colorado state flag. How many lines of symmetry does it have? Well, if you look very carefully, right about there actually is a line of symmetry. Okay, if you cut along that line or folded along that line and folded maybe this top piece over, it would exactly match this bottom piece. Okay, so how about this one? Anybody guess where this one's from? It's actually from Puerto Rico. Okay, And how many lines of symmetry does it have? It has one, right? Actually, has none. Okay, you got to be careful. Stars just tend to trip people up a lot. If we were to draw a line of symmetry where it looks like there might be one, here's what you get. But I want you to be very careful about that star. Okay, so my line of symmetry, which really isn't a line of symmetry, it's just a test, is in the middle, okay, of this red, so we're pretty spot on. But you can tell if I folded this star over here, the point would end up going like right there. Okay, well, there's no white star there where I just drew that little black piece of triangle. So yeah, that unfortunately does not have any lines of symmetry, but that's okay. All right, so as a recap, let's just go through what we've learned real quick. Okay, reflections. Okay, it's a type of transformation in which a figure is reflected or flipped across a certain line. Okay, the common reflections we talked about were reflections in the x-axis, which is that right there, and reflection on the y-axis, which is our vertical axis. Okay, let's make sure we're understanding with those. And I guess probably the most important part of these is when you reflect in the x-axis, multiply the y-coordinate by -1, you leave the x-coordinate alone. When you reflect in the y-axis, you multiply the x-coordinates by -1, but you leave the y-coordinates the same. Okay, tested things to see if they were a reflection or not. And then we lastly talked about lines of symmetry. Okay, creating identical images. And we talked about Colorado and Puerto Rico. All right, so the last thing I really want you to do is I want you to draw a box. Okay, draw like draw a rectangle. In that rectangle, I want you to put another rectangle. Okay, in this rectangle, I want you to draw a smiley face. As symmetrically as you can. Okay, and I want you to tell me within a trapezoid. You're okay, again, I'm telling you to do exactly as I'm doing. Okay, I promise you it'll make sense. Okay, so in this trapezoid, I want you to write how many lines of symmetry this has, and that will be the last thing. And of course, well, we got one right now there, no, but right down the middle, there would be one line of symmetry. Okay, I want you to write exactly like that. That's all I have for you guys. I will see you in class.